All right. So this is a little bit of the kind of horse behind the cart, but when Brian and Tamara talked about how we got to the sites, the regions that we um, rolled out last year, we also want to talk a bit about how we landed on those 13 regions, almost quite literally landed on those 13 regions. And so what I'm going to do today is sort of take a step back and talk through the process that we use to get to those regions. Brian talked a little bit about how we went from potential candidate sites to larger regions for him to do the assessment, but I really do want to get back to how we landed on these 13 regions. So next slide, please. Okay, so everyone has seen this figure now multiple times. It's seared into your collective brains. Did update, fortunately, the Viper landing region, now known as Mons Bhutan. So these are the 13. But of course, they weren't always the 13. We didn't start with this. It actually was quite an intricate process, as it feels back to the early days of the pandemic to get to candidate landing regions. And so the work to get to here took a lot of effort from several NASA centers, contractors, and of course community inputs over the previous 3 decades, effectively to get to this. Let's go to the next slide, please. Okay, so we were asked, a group of NASA internal scientists were asked to come up with candidate landing sites. We were asked to basically call the community inputs over the last several decades to come up with sites that could then be fed into the process that Brian outlined. So we started with individual sites. We built out of those larger regions that basically could describe those sites using the 5-meter Lola DEMs to do the evaluations that Brian outlined. So with any of these regions, there are going to be multiple individual sites that we identified as being of science value. Doesn't mean that the sites that we end up going to will be at those sites we started with, but will be near or representative of those sites. I want to be very clear here that none of this is work that we kind of invented. We wanted what we present here and the work that we did to represent community input. If you think way back to the early days of all this, April of 2020, the first lunar surface science workshop actually had a section devoted to it to landing sites. So that was immediate input into this process, was the first of these LSSWs. Next slide, please. So we started with 28 individual sites. The map at the right shows the distribution of those. The colors will become maybe not clearer, but will at least are tied to the sources of the inputs for our 28 sites. We started with areas of extended illumination. We felt that was an important driver for potentially where we go. Not only are we interested in PSRs, but we're interested in the areas that receive extended illumination. We identified targets of geologic interest, again, calling community documents. Clearly, the work of survey over the past almost 20 years now has been vital in identifying, characterizing key South Pole targets, and then other sites of interest that have come from the community over the years. If we go to the next slide, we get really into the details of each of these 28 regions. Now, one thing that you'll see on these sites are kind of an origin, a source for the identification of the 28 sites. Next slide, please. There we go. So you'll see that there's effectively two categories. There are the areas of extended illumination, and again, those extended illumination sites really owe their origin back to some work that a colleague, some of us remember, Ben Bussey, identified way back in the Clementine and the post-Clementine era of areas of extended illumination. The work of Erwin Mazarico and Glaser et al. Have built on that, but identifying these areas of extended illumination became kind of a key foundation for identifying places that are of at least some form of scientific interest. You'll then see a number of sites that are tied to individuals, whether it's Sam Lawrence, myself, Dan Moriarty, Dan and Barbara, or Tony Colaprete and the Viper team. And an important part of this is that we didn't invent those sites. we champion those sites. So when you see a site next to my name or Sam's name, it's not that we pulled those out of thin air. It is that culling of community documents, the work of Gurwinska, Lemelin, Shui Li, for instance, at identifying interesting areas within the Artemis exploration zone. You will, of course, also see that we did assess the Viper sites, the candidate regions that that Viper team was assessing for potential inputs as well. So we really wanted to have a broad swath. Now you might think, oh wow, Noah, you're the project scientist of Artemis 3. The cake has been baked and that you've had a chance to put your thumb on the scale. I'll note that none of the 4 sites that I was championed for ended up in the Artemis 13 candidate regions. So as much as I might be an advocate, I clearly didn't do a good enough job on those sites. But I think that the work that Brian outlined clearly shows that there's a very clear and direct rationale for how we got to those sites. And so one of the candidate regions, sites that I selected was on the floor of Amundsen Crater, which, as Brian lays out very clearly, would be a challenge in Artemis 3. These 28 sites can be carried forward for future Artemis missions. But of course, as the requirements for future Artemis missions are understood, we will grow these lists to reflect community input, as well as what we learned from Artemis 3. All right, next slide, please. Okay, so one of the key portions of this process, as outlined in Brian's talk, was the development of these 5 meter per pixel products from the Lola instrument that really helped Brian outline and define sub-sites within each of these candidate regions. Obviously, all of the regions are within the exploration zone of Artemis, poleward of 84 degrees south. What he did was take a list of 12 regions. We actually added a couple additional regions that were available to us through these 5 meter products, particularly Hayworth and the Faustini Rim A sites were added and present unique opportunities and present, again, opportunities for Artemis 3 to conduct its mission. So that's effectively how we went from 28 sites down to the 13, is the sorts of inputs that the science community has provided over the years, the work of some of the NASA internal teams, as well as then some additional sites that were considered for Viper, all lead to these 13 candidate regions. And again, as Brian laid out, within the region, there are multiple, dozens, if not more, of potential candidate sites that satisfy the requirements that he defined. And again, this highlights how we go from that alphabet soup of sites, NP, A, B, C, none of which outlined in green, again, didn't get moved forward. You'll see a number of regions there that are available at the 5 meter per pixel level from Lola that aren't in green, that are in orange, that were not moved forward. But again, we do have those data products for future site assessment. Let's go to the next slide, please. So here's the 13. And again, we used a number of criteria to not only down select, but then start to evaluate each of these sites, the figures of merit, not only the technical figures of merit, sun, earth visibility, slopes, the availability of multiple data sets, not just Lola data, but LROC, NAC images, stereo-derived DTMs, all feed into our assessment of these sites. And again, from these 13, we will down select to a more manageable handful of sites later this year, and use that moving forward for Artemis 3. Let's move forward next, please. Okay, so I hope that everybody has had an opportunity to review the Artemis 3 science definition report. This report outlines kind of a general science rationale for the kinds of things that we want to do at one of these candidate sites. Now, obviously, there are science questions that are applied to any site that we go to on the moon, understanding regolith formation process, the cratering process, interaction with the solar wind. But some of these regions, and then as we'll hear over the next 2 days, offer varying degrees of intricate science, whether it's local geology, access to deeper, larger, permanently shrouded regions, and the like, that we can investigate at each site. The starting point is this definition report. But again, as we dig into over the next couple of days, we'll learn more about each of these sub-regions, at least these regions, and some of the unique opportunities that they present there. And the next few slides, don't jump ahead just yet, I'll dig into at least our first cut at some of the unique science aspects of each of the regions. Uh, Again, even though it looks like this is a heavily cratered terrain, this is nice, well-developed, mature soils in the lunar highlands. We'll have an opportunity to explore larger craters than we're able to access with Apollo. We'll have opportunities to explore micro PSRs, as Paul Hain has well delineated in several papers. And of course, we'll be on the rim of one of the, well, to me personally, one of the most interesting areas of the moon, the South Pole Aitken Basin. And so we have really unique opportunity with any number of these regions to begin asking questions not only of what's happening on the moon today with interactions with the solar wind and galactic cosmic rays, but of course what was happening on the moon over 4 billion years ago. So one of the key outcomes, I hope, of this workshop here today and tomorrow is that there'll be a recognition of some of the additional products and some of the additional work that NASA needs to request the community to perform. We've seen recently some advances in geologic mapping of the South Pole, and clearly as we get down to some of these candidate regions, we will want to get higher resolution geologic maps created for those regions so that we can indeed do a more detailed site assessments. Of course, wouldn't be worth talking about the South Pole if we didn't talk about volatiles. And I want to make the case that as much as it would be fascinating to go to the interior of Cabeus crater or some of the most hydrated regions of the moon, we're being driven not only by the science, but also by the requirements for safe and successful mission. And so there is a case to be made, I think, that of going to an area that may have moderate to low amounts of hydration as well, in order to understand the general background of the South Pole. Again, we're going to be building on the results of Artemis 3 with Artemis 4 and subsequent missions. Artemis 3 doesn't have to answer every question we have for the South Pole, but I firmly believe it has to lay a solid foundation for subsequent missions. Let's go to the next slide, please. So we developed a brief science rationale for each of the 13 candidate regions. And again, with Mons Bhutan, we have the Viper mission that'll be going there. Of course, we have a number of CLIPS missions that are going to be landing in some of these regions. So there's a lot of work that's already been done to identify some science questions. You'll see that I built some of the rationale for these sites on the mapping work that went into Paul Spudis's South Polar geologic map. There are recent advances and recent updated geologic maps, and so the results from that work have to be fed into this to come up with those key hypotheses that we want to test. I think there's a really important opportunity to understand the ages of some of these ancient features. How old are the pre-Nectarian terrains that have been mapped in the South Pole, and really understand and start nailing down some of the geochronology of this region. Now, if we go another slide ahead here, what I've done and ultimately shared with the Artemis science teams is to try to understand, which of these sites, if visited once by Artemis 3, can offer varying degrees of, let's say, completeness and understanding. Now, as I said before, Artemis 3 doesn't have to answer every single question, but it does need to lay that foundation. Let's go to the next slide, please. So what I did, and this is just a purely purely mental exercise to try to evaluate what we might be able to expect from these sites, is that if we go to any of these regions with an Artemis 3 mission, conduct 4 EVAs over 6.5 days, what do we think we might actually get out of that? Will we be able to answer or address some of the questions that we've raised? So let's go to the next slide. And again, this is all done in the this workshop environment. What we come out of this workshop with is some additional information. Maybe my assessment, the assessment that we've done for some of these sites, is wrong. And so what I'm keenly interested in is hearing from you all about what we might expect at any one of these regions. So in my opinion, if we go to Malapert Massif or Nobel Rim 1, we may have a better opportunity to understand South Pole Aitken Basin, understand volatiles, whereas with some of the blue sites that I've ranked in blue, we may not get a complete understanding, but again, start to address those questions that could be addressed or answered by subsequent missions. Again, trying to take a holistic view of Artemis, that it's not a one shot, but that we'll have Artemis 3, 4, 5, ultimately to an Artemis base camp to try to disentangle some of these sites, I think is really important. All right, so let's go to the last slide here and kind of round out this introductory session here today. I'm really eager to hear from you all in the community. We want to use science as a foundation for evaluating the sites. Yes, we'll have to meet and satisfy all of the engineering and landing site safety requirements, but we have an incredible opportunity at any of these 13 regions to conduct some really transformative science. We will feed forward from Artemis 3 lessons to Artemis 4 and build upon that. and ultimately use some of the outstanding science questions for Artemis 3 to help factor into Artemis 4's site selection process. I think it's, my philosophy on this is that Artemis 3 may be the most restricted in terms of where we can go, but as we learn more about the system, as we learn more about conducting South Polar field operations, we'll be able to loosen some of those requirements and really push the limits of where we can go with Artemis 4 and those missions that are beyond. I'm very excited to hear the next day and a half of community inputs. This is critical, and as Sam said at the start, I'm really, really eager to make this workshop as informative, not just for you all in the community about what we've been doing internally in NASA, but also vice versa, to hear more about the kinds of science questions that you're all excited to have us answer with the Artemis missions to the moon. And with that, I'll pause and have time for questions or traverse right into a break, whatever Dr. Lawrence wants us to do. And I see my old office hallmate, Jim Rice, asking a question. What is that manageable number of sites that will be carried forward? I think we're all thinking somewhere in the 5 and below number. Ultimately, for crew training purposes, we want not to have to prepare for 13 sites. That's going to become an incredible number of materials to train a crew on. I think we're all kind of bookkeeping in our mind, no fewer than 3 for actual hardcore crew training, but ultimately probably 5 after this summer will be carried forward for further analysis. You're welcome, Jim. I'm going to be very careful not to go all the way through the chat, thinking iteratively, should the first site be the best site to relay, widen some visibility constraints in future missions? That's a question from Alexander Krogan. Alexander, certainly that could be a factor, but right now Artemis 3 doesn't have any plans for deploying a comm structure. Certainly there are some of the candidate 13 regions that would provide potential value for building up a communications network, but at this point that's not part of the immediate consideration for Artemis 3, but certainly as a potential for other robotic missions potentially could do that as well. I'm going to try to go up the chat window because as the
just break in here for a second. We'll take
no,
a couple
Sam,
minutes of questions, and then we have a break scheduled at in a couple of minutes. But I did want to point out that the let's see here. There is a question here about the Artemis base camp sites and criteria being used to identify them, which is a really good question, and I want to emphasize those are just candidate sites. And they presently float to the top under some evaluation metrics, but they are what you might expect. It's proximity to potential volatile resources for economic development and proximity to illumination to provide long-term power and a stable thermal environment. So it's not rocket science, as the saying goes. And the other thing about the initial 28 sites, Mello, is that they were originally selected not just with science in mind, but also with some vehicle constraints in mind. They were all selected to be relatively level terrains and illuminated areas based on the NASA reference lander at the time.
Right. We weren't, as much as I wanted to propose a mission to land on the summit of the Amundsen Central Peak, I was loudly told not to do that. So we did go in with some a priori knowledge of what would constitute a safe landing site, even if some of the safe landing sites we considered were not necessarily going to satisfy all of the requirements that we are now working towards. Okay, let's see. I've got a bunch of questions let's see. Okay, Jack is asking the simulator available for training. Jack, that's being worked right now out of Langley. They have a simulator that they're developing in terms of actually recreating not only the cockpit mock-up, but also windows, displays, what the crew members will actually experience. It does have some range of motion as well, and I know that team has been working with some other NASA centers, particularly Ames, at how to recreate some of the motion that the crew members may experience. So not just simulations, but actual simulators that crew members can stand in and feel like they're at the top of the starship. Let's see. Where are we here? Jack has also emphasized the sampling of boulders. So one of the ongoing processes is identifying boulders, site evaluation processes, identifying boulders within these candidate regions. as a landing hazard, but as I say, every boulder that may be a hazard becomes an immediate target for sampling. Now, we are landing at the summits of most of these massifs. The areas that we are considering are all kind of on elevated terrain. So at this point, the Apollo 17 station 6-7 example of sampling boulders that roll downhill is not necessarily something that's driving us, but certainly identifying boulders that are either exposed along the connecting ridge. There are a number of areas that appear to be outcrops or appear to have some sort of cluster of boulders, and certainly those would become compelling science targets. All right. Dean Epler says it's probably too late to do something that he's answering an above question. I'll just move on to the bottom of the question list here. So yes, let's JW Luna's question. Great last name, JW. Each of the candidate regions is larger compared to the exploration distance. So as Brian outlined, within the regions, we use that to develop a database of candidate sites that satisfy the exploration, the safe landing safety requirements. Once we down select to 5 sites or multiple sites within those regions, the down selection from those work based on specific launch opportunities. And Brian and Tamara, feel free to chime in here, as well as the science that can be accomplished at any of those potential sites. If it gets down to it that we have a number of candidate landing sites that are all of equal landing safety and all of equal opportunity to launch on a given date in 2025, we will then be able to factor in the science, and that could become a deciding factor in which one of those we go.
Yeah, there's some nuances. I see some folks pointing out how large the regions are, and so some of our teammates pick on me because I like to be very specific about regions versus sites. So we are looking to prioritize the 13 regions this summer to then start focusing in more on maybe the top 5 regions sites and how we go from there. So we are looking to prioritize the regions this summer, focus on those top regions to really dig into those sites. And as Noah's explaining with Dr. Brian Welch's work with SpaceX and other CASA stakeholders, looking at the vehicle capability of those sites within those regions and where we can safely land the crew. And then the delineating factor between, say, you have 5 sites within a region that provide us safe landing capability and mission availability equally, then we can layer in the scientific figures of merit across those 5 potential sites in that region and which one helps meet the most objectives scientifically. So that's the path we're going to try to step through for Artemis 3.
And I do want to emphasize an important point that Sam has in the chat that clearly I misspoke. We will go to fewer regions later this year, so go from 13 down to the more manageable number, and from that, identify specific sites at a later date. Just put that out there so it's part of the transcript.